too late. So, oh, I have a ton of yellow forms. Give my test. I'm on a short leash, so you take, yeah, pass it if anyone needs it. Right? The yellow forms. Okay, does everyone know where Palios' office is? The new wing, like the foreign language. Okay. Okay, guys. I'm going to come around. We'll talk about the homework. We'll have a decent amount of time to talk about the homework today. I just have a little bit I want to get across to you. Oh, this is too bad. All right, that's better. What you have in front of you, and actually took a picture. This was from an AP exam. I just changed the question, where they gave you a graph and they told you it was F prime, and they actually gave you all these areas. Talk about a gift, right? You don't have to figure out any areas. I think this was 2012, maybe. I'm not sure. So anyway, there are two ways that a problem can be presented that are basically the same. In other words, you're looking at a graph for the derivative, and then you got to answer questions about the function. So I wanted to, sometimes you'll be given an accumulation function, and sometimes they'll just say, hey, here's the derivative. So I just wanted to make sure that you were comfortable with both. Oh, thank you. Don't even look at any of this. This somehow got, I don't know what happened. Every day. One thing I do want you to note, on your paper, it says F. Could you just change that to a G over here? I have two types of AP questions, and I just want you to be aware you're doing the same thing for both. It's just if you're given an accumulation function, g of x is equal to the definite integral from 1 to x. Now I had to make it of f prime of t, okay, so that it would work with that graph. Right, so that's not a mistake. But when you're given an accumulation function, no one's going to tell you to do this, but what should you do? Derivative, right? So let's just together, what would g prime of x equal? F prime of x. Nice. Okay. Remember, we're just applying that second FTC to find the derivative, right, of a definite integral. It's derivative of upper, which would be 1. Plug in the upper. That's why it's f prime of x minus derivative lower 0. So what we're looking at in that graph above there is g prime. F prime is the same as g prime in this case. Well, give or take a constant. That's a good question. If their derivatives are the same, then they have the same shape, but one could be up higher than the other. Okay? Yeah. The derivative, I think you're being thrown because there's a derivative here. What we're used to seeing, what if I asked you, let's say this is a different problem, let's say h of x is equal to the definite integral from x to 3x squared of t plus 1 dt. This is an accumulation function. I made this a little more complicated. All right? So if I ask you to take the derivative, all right, we apply the second FTC. When we did it in class, what we did, we took the antiderivative first. We figured out what the function looked like. Then we took the derivative. But then we said, oh, there's a much quicker way to do this, to take the derivative. Jen? Exactly. You take the derivative. You start with the upper limit. So the derivative of the upper limit would be 6x. Then you plug in the upper limit. So everywhere you see a t, you just plug in the 3x squared. So times 3x squared plus 1. So derivative of upper, plug in upper, minus, right? And then you plug in the lower, so it would be just x plus 1. And that would be the derivative of that one. Well, what we have in this one here is much easier than that. Okay? So to take the derivative, first we do derivative of upper, 1, plug in upper, f prime of x, minus derivative lower, that's 0, so we don't even write. Okay? Now, since you realize at this point that what you're looking at is g prime in that graph above, you can get g of 4, right? And I'm going to let you guys do this, but just using this definition for g of x, if you want g of 4, what do you use? What do I write? G of x is a definite integral from 1 to x, so what's g of 4? 1 to 4 of f prime of t. We're just plugging in 4 for the x. Don't worry that it's called f prime this time instead of f. The point is, if you have to evaluate the definite integral of some function, as long as you have the graph of this, even if it's called Fred or Joe, it doesn't matter what it's called, as long as you have the graph. Yeah, because I know that that's what's throwing you guys. It doesn't matter what it's called. If you have the graph and you want to Fred, that's so weird. Look, I didn't know that. He has a big sign saying Fred on it. Wow, that was great. Yeah. Sure. Okay, now what do you do? So you want to get the definite integral from 1 to 4 of f prime of t. Area above minus area below, between 1 and 4. So what is area below then? 0. You take whatever, they gave you the areas, right? Yeah. So you're going to do the other one too, but with the other one, when you go to do it, just remember you can only use area above minus area below if the lower limit is less. So if you have to switch them, you got to negate it. So you're going to figure out those, okay? Now, the second type of problem like this on the AP exam, they don't make up any accumulation function. They just say, hey, that's the derivative of the function, the same graph up there, and we give you 1 point on the graph of the function. I want to see if anyone remembers. If they tell you that f of 1 is 5, Gina, I think you know this. How would you get f of 4? Nice! Of the derivative of that function, a prime, and you can call it x or t, I don't care what you call it, it's the same thing. That's how you're going to do it. Remember the f of b is equal to f of a plus a definite integral from a to b, the derivative? Okay. The f of 4 is the b. The a is the 1. Okay? This comes from the first fundamental theorem of calculus when we took how to find the definite integral of a function and we moved things around. Remember, so what we're using for these is the fact that f of b is equal to f of a plus the change in the function, which you get by taking a definite integral from a to b of the derivative of that function. Mm-hmm. Yeah, you could use because you already figured it out. You still, if you were given this problem, you'd still have to look at the graph of f prime and do area above minus area below. Yeah, yeah. These, and again, I thought it was a great question. Or Jillian, you said, does that mean f and g are the same? Well, you're not going to get the exact same y values. They have the same derivatives. Okay, so they're the same shape, but one is up higher than the other. Okay. So see what you can get. You can talk to your neighbor. I'm just going to check homework. Yeah. They have to give you a point. No, like whatever that number they give you, it will become your lower limit. Okay? Yeah, like I'm making a match. Yes. Yeah. Yep. Yes. And then you're going to have to switch them if you want to get that from the area above minus area below. Okay, let me check home. Okay, so what did we we get for g of 4? When you look back at that graph, wait a minute, guys, pay attention now, okay? We said g of 4 was a definite integral from 1 to 4 of f prime. So we look at the graph of f prime between 1 and 4. Area above is 6 minus area below is nothing. 6 minus nothing is 6. All right, so we got that one. Let's look at the next one. G of 0 would be the definite integral, and we just have to look at the definition for these. From what to what? 1 to 0 of f prime of community. Okay? If I want to use area, which I have to do to get this value, I got to switch them. So when you switch them, limits of integration, so the lower limit's less, what do I got to put out front? Negative. Definite integral from 0 to 1. Right, let's see what the definite integral from 0 to 1 is. We look back at the graph. From 0 to 1, what's the definite integral? 2, because area above is 2, area below is 0. So if the definite integral from 0 to 1 is 2, what's our answer? Because it was the opposite. Negative 2. Bam! How many people got that one? A couple? A couple people got that one right? Oh, yeah. Yeah? All right. Negative 2. Okay, we started this one out. We said f of 4. This one, we don't have an accumulation function to plug the 4 into. We have to use that first FTC. We take f of 1, which is 5, and we add the definite integral. But we already figured that out, right? So it's 5 plus 6, which equals, I love it. F of 0, got to erase this, is, what would I write first? F of 1, because that's the point they gave us. Oh, you're getting fancy on me. Oh, all right, well, I'm going to write out what it is first, and then we'll switch it to the minus. So it'll be f of 1 plus the definite integral from 1 to 0 prime. Yes, and you're right. We would switch it to get that lower limit less. All right, so f of 1 was 5 minus, and what was the definite integral from 0 to 1? So it was, okay, so what am I going to have, 3 or 7 is what I'm asking you. Big fight broke out. Yeah, because it's minus the definite integral from 0 to 1, and that's 2. Because if you look from 0 to 1, there's 2 above and 0 below. So the answer is 3. Then you just made it down. That's fine. You could say it's 5, and then plus negative 2, or just 5 minus 2, as long as you get 3. Okay. But these are fun. I got to tell you, I do want. Yeah. Okay. Oh, that is so not true. That's so not true. Okay, we're going to get back to those homework questions, but I need to really, sometimes the words trip us up, and when things are similar, I really like to juxtapose them, if I can use that word. All right. I want you to see the difference, because, you'll be asked for the average value of this function or the average rate of change of that function, and I want you to understand the difference between the average value of a function, the average y-coordinate on a graph, or the average rate of change of a function. Rate of change means slope, okay? So if you're asked for the average value of some function over some closed interval, what that means is you got a graph, the y's are changing, right? They could be going up. The average value of a function is the average y-coordinate. If you could take the average of every single y-coordinate of every point, that would be the average value of a function. And the way we get it is with the mean value theorem for integrals. We did that like a week ago. I don't know if you remember. The average value of a function is the average y-coordinate of that graph. The value of the function is the y-coordinate. Now, the way we get it with the mean value theorem, do you remember this? It's 1 over b minus a times the definite integral from a to b of the function. That's how you find it. That's what you have to do if you're asked for the average value of the function from a to b. You take the definite integral of that function from a to b, and you multiply it by 1 over b minus a. Now, graphically, because it's always good to have a sense of what you're finding, the average y value of a graph, over some closed interval turns out to be the height of a rectangle that would have the same area as the area under the graph from a to b. So I put it like here. See, the definite integral from a to b, that's this area, right? The average value of a function from a to b would be the height of a rectangle with that same base that would have the same area as under the curve. No. Okay. All right, guys. Okay, we are going. What I want to do is Okay, so that's how you find the average value of a function. Okay, you just get the definite integral and multiply by 1 over b minus a. Now, if you're asked for the average rate of change of a function over a closed interval, that you're talking about the average slope, not the average y value. You've got the slopes, they're changing between a and b. The average slope, the average rate of change is the slope of the secant. It's just the change of y's over the change of x's. F of b minus f of a over b minus a. So average rate of change, average slope, just use slope formula. Average value of a function, you need to multiply the definite integral by 1 over b minus a. So I want to do both, just one example, and we'll get to the homework. Oh, don't look at this. Nice. Okay. We have an example here. F of x equals x squared. We have a parabola. Okay. First thing we want to find is the average rate of change of this function on the interval from 1 to 3. So I've drawn a graph of the parabola. Okay. 1 to 3. How are we going to find the average rate of change? Change of y's over change of x's. So what do we got to find? Okay. So yeah, we have to. So as far as what we have to find here, what should I write for the numerator? F of 3 minus f of 1 over 3 minus 1. What's f of 3? 9. F of 1. 3 minus 1. What do we get? 4. So if you have this parabola and it's drawn, as far as the graph goes, between 1 and 3, here to here, even though the slope is changing, sometimes it's less than 4, sometimes it's greater than 4, this average slope, the average rate of change, which is the slope of the secant, equals 4. Slope formula. Got it? Now, we have, in the other part here, whereas for the average value of our function y equals x squared on the interval from 1 to 3. Average value. So we have y coordinates that are changing, from the y's go from 1 up to 9. We want to know what the average y coordinate is. So what do we do for this one? What do I write for it? 3 minus, good. Our function is x squared. Okay, let's just do this one. So what do we do to get the definite integral from 1 to 3 of x squared? The what? Antiderivative, right? got to take the antiderivative of x squared, but we won't go to the calculator. This is an easy one, right? X to the third over 3, 1/3 x cubed. You write what you want. So let's leave the half out here for later. All right? So we'll write what I have down here. Yeah. So the antiderivative of x squared is 1/3 x cubed. We have to evaluate that from 1 to 3. All right? No. Wait, what do you have for an answer? Anyone else get that? Yes, because it's right. That's why you got it. Yes. So yeah, you plug in when you're doing it, when you actually get the antiderivative yourself, you plug in the upper limit first. So 1/3 of 27 minus 1/3 of 1. So you have 27/3 minus 1/3 inside. So we have 1/2 of 26/3, which is, as you told me, bless you, 13/3. 13/3. What is that around? Right, I guess a mixed number. How would that be? A little more than 4. 4 1/3. Now, again, so it's not the same, and so it definitely makes a difference here. But when you find that, the average value of the function we got was 4 1/3. That means that if I drew a rectangle from x equals 1 to x equals 2, oh, this is 1, sorry. From x equals 1, okay, to 3. And I made the height 4 1/3, 1, 2, 3, 4, a little higher. So if I went up to 4 1/3, and I came up with this rectangle here, this rectangle would have the same area as the area under the curve from 1 to 3. So it should have the same area as all this. Well, that came from the derivation of it that I don't want to go back and do right now. Okay. But when we were trying to find the average value of a function by adding up just some of the y's, and then we took the limit as we added up more and more y's, and we got the definite integral. So, but that's what it represents. It's the height of a rectangle that has the same area as the definite integral. It's the area under the curve. Okay, now we can have some fun talking about the homework, and I hope we can clear up some stuff. Don't worry, I got a better thing now. Okay. Now, what's really important, I gave you the answers. I want to show you how this works in case you're not familiar. Now, you're not going to be able to really read what I have here. Let me see. Did I get that here? I'll just open up one of them. The scoring guidelines that you can get on the internet for every free response from every AP exam, there are 2 columns. And there we go. Just put it over here. Oops, where did that go? Yeah, you're right. Okay, is this the right one though? Which one is this? No, it's not the right. I don't know which one this is, but it doesn't matter. I just want to show you how these scoring guidelines work. Every free response question is worth 9 points. 9. Out of the whole test has 108 points. Okay, so there are 108 points on the AP exam. You have 54. Oh, I can't write on this. You have 54 points for the multiple choice and 54 points for the free response. So you have 6 free response questions, 9 points each. Okay, so that makes up half the points that you can get. You don't have to get 108 out of 108 to get a 5. You have to get like a 70 out of 108 to get a 5. So it's not like you have to, in general, I say if you can get 2/3 of the points, you can get a 5. Now, it's not easy. I'm not saying it's easy, but it's not, it's manageable. Okay? Yeah. So I don't want you to be so scared saying, oh, I don't get every part of the question. If you can get 6 out of 9 points on average out of every question, you should be fine. Yeah, you don't want to waste a lot of time on something that. Okay. Now, so what I've given you. Oops. Okay, I'm doing bad with this again. Let me do the 99 one here. Well, on your scoring guidelines, let me just try one more time, see if I can get that up here. Scoring guidelines for the 99. This should be it. No. Yes, scoring guidelines. Okay. If I go to, I mean, you have it, but I just want to show you how it works. It's not going to work. Come on, let me just go back here. Okay. So they give you the right answers, the correct answers on the left. Okay. The left column. These are your answers. Then in the right column, that tells you how many points they're going to give you for each thing you did. Okay, what they're looking for. All right, so you can see how those 9 points are divvied up and what they expect. So what I want to do is look at some of these. I'm going to psych to do that. I have it on better print. So if like the first one, this is the 99A. You had to get G of 4. You used the definition. You had to take the definite interval from 1 to 4. This time, though, they didn't just give you the areas. You had to find them. So you had to break it up. If you were stuck trying to get the area of this trapezoid here, you could have always broken it up to be a square and a triangle. In fact, that's what they did. If you look at their answers, they say that the definite interval from 1 to 4 is 1. That's the area of the square. Plus 3/2. That's the area of that triangle. Plus 1/2. That's the area of this triangle. Minus a half. That's the area of that triangle. So when you take 3/2 plus 1, that's 5/2. Plus a half minus a half, back to 5/2. That was the answer for G of 4. So you had to get the areas. And G of -2, you had to get the definite integral from -2 to 1. Okay. Sorry, from 1 to -2, but switch it. So from 1 to -2 to 1, if you were to take this area, triangle, 1/2 base times height, 1/2 of 3 times 4 is 6. So the definite integral from -2 to 1, area above minus area below would be 6. But you had to switch it here. That's why it's -6. Because it was, the lower limit wasn't less than the upper limit. So you had to switch it. That's why they got -6. Questions on the first one? So this is the 99A. Oh, they wanted the absolute min. As far as what you need to show, first of all, where can the absolute min occur? If you're looking at the derivative, what are the only endpoints, or where it goes from negative to positive? It never goes from negative to positive, right? So you'd have to say something like the absolute min can only occur at the endpoints or when G prime goes from negative to positive. Yeah. Yeah. Okay. And then you have to, get G of -2. Oh, we already got that. That's another thing to remember when you're doing this. Always look up at like parts that you already did. Answers, you've done the work already. Usually they take stuff you've done and they bring it down. Like G of -2, that was part of the part A. Okay, but they say that if you carry if you get a wrong answer but you use it correctly in the next part, you're supposed to get credit for the next part. So, well, like in other words, they say, so to find out the absolute min, you're going to have to get G of -2. But we already did that before. You know, we said it was the definite integral from 1 to -2, which turned out to be -6, right? Oh, because it said what is the absolute? What did it say in the scoring guidelines? See, the thing is, when they say what's the absolute min, I know they're looking for the y. If they say where is the absolute min, they're looking for the x. You could always write the point on your paper and then pick the one you think it's going to be, you know. Um, so that one we got was -6, and then the other end point, oh, we got that also in the first part. Oh, that's great. So g of +4. I'm sorry, we've already got that. I forgot what that was. Oh, that was 5/5, right? It was a definite integral from 1 to 4. If you're not sure, just say the absolute min occurs at, you always keep both, occurs at x equals -2, the absolute min is -6. If you're worried that you're not giving a piece of information, you know. I see I put the answers up here. Oh, the point, they wanted a point of inflection. So what were you looking for in this graph? This max or min, you're looking for where the slope changes sign. So they wanted you to consider these two values of x. One, there's going to be a point of inflection on the graph because the slope of g prime, the second derivative, changes sign. You'd have to say something like that. So there will be a point of inflection on g at 1 because the slope changes sign, but not at 2. The slope is negative, so the second derivative goes from negative to negative. It's not changing sign, no point of inflection. I know I'm not getting to your questions. What, is there one maybe I could just, oh no, it's like the end of the period. Was there something you want me to focus on next time? If you look through these, yeah, 2003C. Oh yeah, 2003C. So you had to get the average rate of change. Average rate of change. You did of G. So you had to do the G of whatever. Did you get 7/3 for that? Oh, okay. So, okay, this one was really easy though, because then it says for how many values of C does G prime equal the answer you got? The answer you're supposed to get here is 7/3. Uh, so how many values does it equal that? Twice, here and here. It crosses that graph twice. If you want to see if you want to solve an equation, you can graph each side separately and count, and wherever they intersect, that's when they're equal. Tonight, the one you need a calculator for, the other you don't. You have two problems. Yes, you need a calculator on one because to get the definite integral, they're not going to be nice shapes. You're actually going to have to go to. Yes.